This is the last section where we are going to talk exclusively about ions. We'll talk about other things for the rest of the unit. This doesn't mean that we'll never talk about ions again in this course. We will talk about them a lot, but this is the last section where we exclusively talk about them. In this section, we're talking about something called polyatomic ions. I want to break down this word just in case it's a little bit intimidating. The prefix poly means many. Atomic means atoms, obviously. And we've already talked about what ion means. Ion means that something has an electrical charge. So a polyatomic ion is basically a group of atoms that is electrically charged. So here we're not talking about one single atom that has an electrical charge. We're talking about a group of atoms that as a pack, as a group, has an electrical charge. So I don't want you to necessarily memorize the phrase polyatomic ion. I just want you to have a sense of what it means, and I'll give you a few examples of polyatomic ions in the next slide. So here's a table showing a bunch of different polyatomic ions. And sometimes this can be a little bit confusing to the student, so I want to go over this in a little bit of detail. Again, you don't need to memorize each of these names or these formulas, but let's talk about this first thing here. This is an oxygen atom, a single oxygen atom attached to a single hydrogen atom. And it just so happens that if these two atoms are grouped together, they will very often have an electrical charge of -1. What I am not saying, I'm not saying that the hydrogen atom all by itself has a charge of -1. What I am saying is that the O and the H together have a charge of -1. So that's why they're called a polyatomic ion, because that ion over there is actually made of at least two different atoms. And in this case, OH with a charge of -1 is called a hydroxide ion. Same thing here. It's not just the nitrogen that has the negative charge. It's the group of these things. It's the carbon and the nitrogen together that have a charge of -1. And carbon and nitrogen with a charge of -1 is called a cyanide ion. Here, this one is, again, a little bit more complicated than the ones we've talked about before. I won't go through everything here, but I want to go through a handful of them. Here, we have 4 hydrogen atoms. That's what the 4 means. The subscript of 4 means 4 hydrogen atoms, and those are attached to 1 nitrogen. And as a group, all 5 of these atoms, the nitrogen and the 4 hydrogens as a group, have a charge of +1. So you can think of all of these atoms as traveling in a pack. They always travel together, and when they travel together like this, they have a charge of +1. And in this case, this is called an ammonium ion. And you can keep reading down this list, and you will see that these groups of atoms, the NO3, will have a charge of -1. The NO2 will have a charge of -1. CO3, that means 3 oxygens attached to 1 carbon, has a charge of -2. And so these are all just different examples of what are called polyatomic ions. So it's not just single individual atoms that can sometimes have an electrical charge. You can think of atoms traveling in groups or in packs, and those groups can also have an electrical charge associated with them. And some of those are shown here. So as an example, here's a question. What is the formula for calcium carbonate? And before you pause this, I will tell you that calcium has a preferred charge of +2. So if I asked you, what's the formula for calcium carbonate, we would look up, well, first of all, let's write down that calcium prefers to have a charge of +2. And then let's look up carbonate. So here's carbonate, and this is the formula for carbonate. And so let's write that here, CO3. It's 3 oxygens attached to 1 carbon, and carbonate, all of these atoms as a group have a charge of -2. So how many CO3s do I need to neutralize 1 calcium? And again, you can pause and think about this. But the answer is pretty straightforward here. You need 1 group of these, because 1 group has a charge of -2, to neutralize 1 calcium atom, because the calcium has a charge of +2. So the formula for calcium carbonate would be CaCO3, and that's it. Here is another question. The question is, what is the formula for magnesium nitrate? So again, this requires you to know, and I'm just telling you at this point, that the preferred charge of magnesium is positive 2. So let's write it there. And let's look up nitrate. Nitrate is over here. And the formula for nitrate is NO3 with a charge of negative 1. So what I'm basically asking, and I'll write the 1 there, is how many groups of NO3s do I need to neutralize a single magnesium ion? And since every NO3 has a charge of -1, I'm going to need 2 of these groups. I'm going to need 2 groups of NO3s. So let's write a second one here. -1. I'm going to actually need 2 of these to neutralize a single magnesium ion. And so the formula is written this way. If you wanted to, you could write it this way, which is a little bit weird, but I'm just going to show you a weird way of writing it before I show you the proper way. You could write it MgNO3, but there are 2 of them. So you could write NO3 twice. And you could say this is the formula for magnesium nitrate, because you actually need 2 groups of NO3s, or 2 groups of nitrates, to neutralize 1 magnesium. The preferred way, the way that chemists really do it, is they write it like this. They write the magnesium in the same way that we wrote the magnesium above. But then they write a single NO3, but we said that there are 2 groups of them. So we put a parenthesis around the NO3, and we write another subscript 2 outside of the parentheses. The subscript of 2 here, outside of the parentheses, means that there are 2 sets of everything that's inside of the parentheses. There are 2 sets of NO3. And so this is the preferred way of writing the formula for magnesium nitrate. You would write Mg parentheses NO3, close parentheses, and then a subscript of 2. And you should probably get used to realizing what the subscript here outside of the parentheses means, because it will show up a fair amount in this course. So that's it for ions. We are going to spend the next section introducing a different way that atoms can attach to each other. So ionic compounds are when you have groups of atoms attached to each other because of opposite electrical charges. We're going to talk about a different way of attaching atoms to each other in the next section.